Good morning all of you. In the previous class we have seen that we are solving the questions based on derivative and we are solving questions of your exercise of NCERT. So let's see, continue the same class. So our first question is find the derivative of cos x by the help of first principle. So what we will do, first we will write the formula f dash x is equal to limit h tend to 0 fx plus h minus fx by h. So let's see. So limit h tend to 0, our function is, here is x, so here is x. If here is x, our function is x plus h, so we write x plus h. So we write cos x plus h minus cos x by h. So let limit h tend to 0, cos c minus cos d. The formula of cos c minus cos d is minus sin c plus d by 2 into sin c minus d by 2 and divided by h. Okay. Now limit h tend to 0 minus sin 2x plus h by 2 and this will be cancelled, sin h by 2 and this is h, which is I am writing by here. Okay. Now we write limit h tend to 0 minus sin and we write x plus h by 2 into sin h by 2 by h. Okay. So here will be 2 in the formula. So now this 2 we will take and write in the denominator of h. So we make the formula limit h tends to 0 minus 2 sin x plus h by 2 sin h by 2 divided by h by 2. Okay. So now put the limit we take, we are writing here minus 2 sin x plus h by 2 and limit h tend to 0 sin h by 2 h by 2. So the value of this will be 1 by the help of standard result. Okay. So and here will be also minus 2 limit h tend to 0 and this 2 will reduce. This 2 came here. Now we write this is 1. So we write put the limit as 0. So we get minus sin x. So the derivative of cos x will be what? Minus sin x. Okay. What we have done? We have taken f(x) is equal to limit h tend to 0 fx plus h minus fx by h. So limit h tend to 0, function is cos x plus h minus cos x by h. Limit h tend to 0 minus 2, we know the formula cos c minus cos d minus sin c plus d by 2 into sin c minus d by 2. So we apply here and divided by h and this is 2 with the formula equal. Now after solving we get 2x plus h by 2 and sin h by 2. We write this h by this h by here and minus 2 sin x plus h by 2 sin h by 2 and we have taken this 2 to the denominator of h. So we write here. Now we take the limit with both functions, this function and this function. There are two functions after the function. So we write limit here, limit here. So this is the value which will be 1 and this will be sin x. Now we will see the next question. Next question is, find the derivative of the following function. So next question is question number 11. First is fx is equal to sin x into cos x. We have to find the derivative of this function. So f dash x is equal to, we know that this is product of two functions. So we apply the formula, first function, second function. So we write first function differentiation of second function plus second function differentiation of first function. Now sin x differentiation of cos x is minus sin x, cos x differentiation of sin x is cos x. So we write minus sin square x plus cos square x, cos square x minus sin square x. It will be cos 2x and it will be our answer. Okay. Next question is, next question is fx is equal to 5 sec x plus 4 cos x. Now derivative of this function is called 5 differentiation of sec x plus 4 differentiation of cos x. Okay, so we write about 5 differentiation of sec x is sec x tan x, sec x tan x, and cos x is minus sin x. So 5 sec x tan x minus 4 sin x. So it will be your answer. Next question. Differentiation of Cot X. Okay, so we have to find the differentiation of this function by first principle. So let f dash x is equal to limit h tend to 0 fx plus h minus fx by h. Okay. So put the value limit h tend to 0 cot x plus h minus cot x divided by h. So limit h tend to 0, this can be written as sin x plus h minus cos x by sin x by h. Now take LCM. Limit h tend to 0, what will get? Sin x plus h sin x. This will be cancelled. Cos x plus h sin x minus sin cancel. Sin x plus h cos x and the whole divided by h. So limit h tend to 0 cos a sin a cos b minus cos a sin b. So it is the formula of sin a minus b. Okay. So we write sin x plus h sin x h. Okay, write it. Now let limit h tend to 0. This is sin minus h, so we can write minus sin h by sin x plus h sin x into h. Now limit h tends to 0. We can write this sin s divided by h. So we write sin h by h divided by sin x plus h sin x. Put the limit 0. We write 1 by sin x into sin x into limit h tend to 0 sin h by h. So this will be what? 1, and here is also negative sign. So we write here minus 1 by sin square x. So we write minus cosec square x. Now it will be the differentiation of cot x. Okay. So what we have done, we have to given the function fx is equal to cot x and f dash x is equal to limit h tend to 0 fx plus h minus fx by h. So value will be cot x plus h minus cot x by h. So what we will do? Now we will write cos x by sin x minus cos x by sin x by h. Limit h tend to 0 cos x plus h. Now take LCM. We get cot x plus h sin x minus sin x plus h cos x divided by sin x plus h sin x into h, this h. Now see here sin a cos b minus cos a sin b sin a minus b. So we write sin x minus h. Okay. So x sin x will reduce. We get minus sin h. Sin minus theta is minus sin theta, so we write minus sin h by this. Now take this sin h and h together and separate the limit. We input the limit sin x into sin x and limit h tends to 0 sin h by s. The value of whole this term is 1 and this will be 1 by sin square x and it will be minus cosec square x. So the differentiation of cot x will be what? Minus cosec square x. Next question is our function is say x. We have to find the derivative of this function, okay, by first principle. So let fx is equal to sec x. Now f tends x is equal to limit h tends to 0 fx plus h minus fx by h. Okay, this is the formula. Now take the function limit h tends to 0 sec x plus h minus sec x by h limit h tends to 0. We can write 1 by cos x plus h 1 by cos x divided by h. We can write this. Now limit h tends to 0. This is take LCM cos x plus h into cos x. Now we get here cos x minus cos x plus h. Okay, and this h is we can write here. Now take limit h tends to 0 cos c minus cos d. So it will be what? Minus sin c plus d by 2 into sin c minus d by 2 and divided by cos x plus h cos x into h. This x and x will reduce. Now we write here we get limit h tends to 0. We write minus sin 2x by 2. So x plus h by 2 into sin h by 2 divided by, and this minus will be here, so it will be plus. So cos x plus h cos x and h. Now limit h to 0. So we write limit sin x plus h by 2 into limit h tends to 0 and here will be 2 with the formula they have not written, and this 2 will be settled in the denominator of h. We write limit sin h by 2 divided by h by 2. So the value of this term will be 1 and divided by cos x plus h into cos x. Now put the limit. We write sin x and this term will be 0 divided by cos x, and this is cos x, and this term will be 1. Okay. Now we write tan x into 1 by cos x. It will be tan x into sec x. So the differentiation of sec x is sec x tan x. Okay. We can find also by the help of the first principle. Look at again what we have done. Sec x plus h minus sec x by h. Limit h tend to 0, 1 by sec cos x plus h, 1 by cos x h. Limit h tend to 0. Take LCM, we get cos x minus cos x plus h divided by cos x plus h into cos x and this h. Now formula of cos c minus cos d is minus 2 sin c plus d by 2 into sin c minus d by 2 divided by cos x plus h into cos x and this h. Now this 2 will be set up in the denominator of h. We write 2 sin x plus h by 2 sin h by 2 cos x plus h into cos x into h. Okay. Now set here limit h tend to 0 sin h by 2 sin h by 2. So it will be what? 1. Now this term sin x plus h by 2 and these terms which are right here, put the limit h tend to 0. So here 0, so it will be cos sin x, cos x, cos x, tan x, 1. So it will be tan x and 1 by cos x. So we write sec x into tan x. So the differentiation of sec x is sec x tan x. We will see the next question. Next question is fx is equal to tan x. We have to find the derivative of this function by the help of first principle. So let f dash x is what? Limit h tends to 0 fx plus h minus fx by h. Okay. So let limit h tends to 0, our function will be tan x plus h minus tan x divided by h. Okay. Now limit h tends to 0, we write sin x plus h by cos x plus h minus sin x by cos x divided by h. Now we take LCM. Okay. What we will do? We take LCM. So limit h tend to 0 cos x plus h cos x. So it will cancel. We write sin x plus h cos x minus cos x plus h sin x. Okay, we have taken LCM of these both. We get it will cancel sin x plus h, cos x minus cos and cos cancel, cos x plus h, sin x. Now see, it is a formula. Check which formula will apply here. Sin A cos B minus cos A sin B. So formula will be got sin A minus B. So we write sin A minus B and divided by cos x plus h cos x, and this h will be also this h, and here will be okay. Now what we will do in the next step, we write limit h tend to 0 sin this x and x will reduce, we get sin h divided by cos x plus h into cos x h. So limit h tend to 0, we write 1 by cos x plus h into cos x into limit h tend to 0 sin h by h. By the algebra of limit, we can take limit with the both function separately. So we write here that limit h tend to 0 1 by cos x plus h cos x, limit h tend to 0 sin h by h. Okay, by the help of algebra function. Now we know that the value of this function is 1, so we place it 1. Limit h tends to 0 1 by cos x plus h into cos x into the value of this function will be 1. Okay, so now what we will do, we will put the limit of the function. Okay, so we get what, cos h is 0, x plus 0, and this is cos x. So we write 1 by cos x, so it will be what, 1 by cos square x. So we write what, sec square x. Okay, what we have done, 1 by cos x plus h into cos x. So put the limit h 0, 1 by cos x plus 0 and 1 by cos x. So if we are putting the limit 0, so we get cos x into cos x, it will be what, 1 by cos square x, and we write sec square x. Okay, so overall what we have get, we have find the derivative of tan x, and what we have find, sec square x. So let's see once again the whole solution. First we have formula f dash x, we write limit h tend to 0 fx plus h minus fx by h. Okay, now we will put our function tan x plus h minus tan x by h, because here is the variable is x plus h, so we change in the variable. At the place of x we write x plus h. Take as we can change this tan and sin and cos, we write here, take LCM. So we get sin x plus h into cos x minus cos x plus h into sin x divided by cos x plus h into cos x into h. Okay, now limit h tend to 0 sin x plus h. This is the formula of sin a minus b, sin a cos b minus cos a sin b. So we write sin x plus h minus x and x will reduce. We get what? Sin h tend to 0 sin x, cos x plus h, cos x into h. Now we separate the limit, we write limit with sin h here, and this h will adjust with this. We know that the limit of this function will be what? 1. So now put h is 0 here, here 0. So we get 1 by cos x, 1 by cos x, and 1 by cos into cos x will be what? 1 by cos square x and it will be sec square x. So the derivative of the tan x will be sec square x by the help of first principle. Okay, thank you.